Hey calculus students, we're here to talk about section 1.2, defining limits and using limit notation. We do have a question here on the top. It says, what does the limit of f of x as x approaches 2 equaling 4 indicate? Okay. More importantly, we're going to talk about in this problem, in this video, what we can assume. But first of all, as you approach 2 from the left or from the right, okay, our function value approaches 4 on either side. So that's what it indicates. However, what we cannot assume, just because the limit exists, we cannot assume that the function is continuous at x equals 2. According to our graph here, we have an open circle at x equals 2, indicating that it's not continuous at x equals 2. So if a limit exists at x equals 2, it could be continuous, but it's not guaranteed. Also, if a limit exists, we cannot assume that a function is differentiable at x equals 2. Clearly, an open circle is a point of discontinuity, and if you are a point of discontinuity, you're definitely not differentiable at that open point. Okay? Even if this was colored in, we would have a corner. And a function is not differentiable at a corner because the slope has an abrupt change from the left to the right-hand side. So, if a limit exists as x approaches 2 is equaling 4, a function could be differentiable, but it's not guaranteed that's differentiable. And lastly, f of 2 equaling 4 could also not be assumed. There could be clearly an open circle like it was before at the very top, at 2, 4. And our function actually could be defined down here at 2, 2. So if a function has a limit as x approaches 2 equaling 4, the function value could be 4, but it's no guarantee that f of 2 equals 4.